Hi everyone, today we're going to be learning about triangles and how to determine if three side lengths can actually form a triangle. So to start off, let's look at these measurements that we have, and we want to organize them from largest to smallest. So 1A has 1 centimeter, 5 centimeters, and 4 centimeters. So we know that 5 is going to be greater than 4, which is greater than 1. How about B? 5 centimeters, 2 centimeters, and again, 2 centimeters. Well, 5 centimeters is in fact greater than 2, which happens to be equal to 2. How about C? 3 centimeters, 2 centimeters, and 5 centimeters. 5 centimeters is greater than 3, which is greater than 2. 4 centimeters, 2 centimeters, and 5 centimeters. 5 is greater than 4, which is greater than 2. So to determine if we can make a triangle, we have a theorem called the triangle inequality theorem. And as you can see from the graphic here, we can make a triangle as long as any side of a triangle is always shorter than the sum of the other two sides. So as you can see, I am stretching point A, point B, and we have a triangle. And if you go to this website, mathopenref.com, you will be able to play with this widget, and you can see that we have the sum of any two sides, and we're trying to compare it to the third side. We can also try to make a triangle using the same website. You can play around with these different lengths. And as you can see, as much as I want to make a triangle, and as much as I move A and B, it's just not going to be working for me. So there's got to be something to these side lengths. And thanks to the triangle inequality theorem, we can figure that out. Okay, so if we have any triangle and we don't necessarily know the third side, we can determine what that third side, the range of the third side, can be by using these inequalities. So we have A plus B, that has to be greater than C. If we have A plus C, that has to be greater than B. And if we have B plus C, that has to be greater than A. So let's look at some examples. We have these measurements, 8, 4, and 1. And I am going to check if the two smaller sides are greater than the third side. If not, then we can form a triangle. So is 8 less than 4 plus 1? 4 plus 1 is 5. So 8 is not less than 5. That means that we cannot make a triangle here. How about 3.5, 2, and 2? Is 3.5 less than 2 plus 2? It is. So we can make a triangle. How about 5, 3, and 2? Is 5 less than 3 plus 2? No, 5 is equal to 5, so those three lengths will not make a triangle. How about 5, 4, and 3? Is 5 less than 4 plus 3? It is. So those three lengths can make a triangle. What are the different types of triangles that we can make? So if you can recall from a while ago, we identified triangles based on the angles, and we said that we can have acute, obtuse, and right triangles. And in the next lesson, we'll be able to figure out, using the Pythagorean theorem, how to determine whether we're having acute, obtuse, or right triangle.